Hello, my name is Daniel, and today we will be going through the AMC 12B from the year 2009, so let's get started. First problem. Each morning over a 5-day work week, Jane bought either a 50-cent muffin or a 75-cent bagel. Her total cost for the week was a whole number of dollars. How many bagels did she buy? We can divide these by 25, right? So to get 2 cents for muffins and 3 cents for bagels, so a whole number of dollars, that would mean 100 divided by 25 equals 4, so that's a multiple of 4. So let's say she bought X bagels, that would mean 3x because 3 bagels plus 2 times 5 minus x because it was a 5-day work week, and then this equals 4 times something, and so that means 10 minus x, 10 plus x is going to be 4 times something. 10 plus x equals 4 times something. That means if that x is 2, then this will be 12, so this will be okay, right? So x is 2, therefore it's B. Number 2, Paul the painter had just enough paint for 30 identically sized rooms. Unfortunately, on the way to work, 3 cans of paint fell off her truck, so she only had enough paint for 25 rooms. How many cans of paint did she use for the 25 rooms? So 3 cans of paint was equal to 5 rooms, right? Because she couldn't paint 5 rooms because she lost 3 cans. So that means 25 rooms. This is going to be 3 times 5, which is 15 cans, right? So it's 15, it's C. Number 3, 20% less than 60 is 1/3 more than one number. Okay, so we have 60, and we have 20% less, so 80% of that, and then equals 1/3 more than, so it's 4 over 3 times something, and so we know that we can erase this 4, and this is going to become 12, and then so to get this away, we can do 3 multiplied, so this is going to be equal to 36, it's D. Number 4, a rectangular yard contains 2 flower beds in the shape of congruent isosceles right triangles. The remainder of the yard has a trapezoidal shape as shown. The parallel sides of the trapezoid have lengths 15 and 25 meters. What fraction of the yard is occupied by the flower beds? We know this much is 15, and the whole thing is 25, so that means these two, their sum would be 10, so each of these would be 5, right? And since they are isosceles right triangles, that means this length and this length are the same, right? So that means this side length, that's also 5. The area of the flower beds, this is going to be equal to this plus this, right? Which is just 5 squared. This is 5 squared, and then the total area, it's over 25 times 5, right? So it's 25 times 5. So these two will cancel. This is 1 over 5. So this is the answer. It's C. Number 5. Kiana has 2 older twin brothers. The product of their ages is 128. What is the sum of their 3 ages? Let's say that the ages are A, and B. A is the age of the brothers, and B is the age of Kiana. So here, their product is 128. So A squared times B equals 128. And 128, we know this is 2 to the 7th power. And this is the product of their ages, and we want the sum of their 3 ages, right? And so here, since the brothers are older, this means that A is greater than B. And so the only thing that is okay for this is when A equals 8 and B equals 2, because this is 8 times 8 times 2. The sum would be 8 plus 2, which is equal to 18. So this is the answer. It's D. Number 6, by inserting parentheses, it is possible to give the expression this values. How many different values can be obtained? First of all, we can just do the normal thing, like that, and so that will be 26. Or we can parenthesize this one in the middle, so that will give us 2 times 7 times 5, that's 70. Or we can do this, so like that will give us 50. Or we can do this, right, and that's going to give us 46, right? So we have these 4 values, so this is the answer. It's 4, it's C. Number 7, in a certain year, the price of gasoline rose by 20% during January, fell by 20% during February, rose by 25% during March, and fell by X% during April. The price of gasoline at the end of April was the same as it was at the beginning of January. To the nearest integer, what is X? Okay, so let's say that it was A at the beginning of the year, and then it rose by 20%, so it's 6 over 5, and then it fell by 20%, so it's 4 over 5 now. And then it rose by 25%, so it's 5 over 4, and times fell by X%. So this is 1 minus X over 100, and this is going to be equal to A, right? And so that means these two cancel and these two cancel. So basically this 1 minus X over 100 is going to be equal to this inverted, which is 5 over 6, right? And so X over 100 is equal to 1 over 6. X is equal to 50 over 3, which is going to be like 16 point something. And so the nearest thing this is going to be is 17, right? So 17 is the answer. It's B. Number 8. When a bucket is 2/3 full of water, the bucket and water weigh 8 kilograms. When the bucket is 1/2 full of water, the total weight is B kilograms. In terms of A and B, where's the total weight in kilograms when the bucket is full of water? Let's say that the bucket's weight is X and the water's weight, that would be Y. And so when a bucket is 2/3 full of water, so it's X plus 2/3Y. This is equal to A. And when it's half full of water, so X plus 1/2Y. This is going to be equal to B, right? And so if we subtract those two, then that's going to give us 1/6Y. This is going to be equal to A minus B, right? And so if we multiply both sides by 3, that means 1/2 Y is equal to 3 times A minus B, right? 3 times A minus B. And so this is going to give us that X plus Y, which is the bucket plus the water. This is going to be equal to X plus half Y plus half Y. So this is going to be equal to B, because it's this much, and then plus this much, which is this. So that's 3A minus 3B. This is 3A minus 2B, right? And so this is the answer. So it's E. Number 9. Triangle ABC has vertices A equals 3.0, B equals 0,3, and C, where C is on the line, X plus Y equals 7. What is the area of ABC? Okay, so it didn't tell us where C was exactly, but then it just said to get the area. That means it doesn't really matter where C is, right? And so if we just draw this, and this is A and this is B, so this is 3, this is 3, so this is A and this is B. And C is on this line like that, so this will be 7, this would be 7, because this is Y equals negative X plus 7. Since it doesn't really matter where C is at, let's say just C is over here, right? Let's say this is C, and this is A and this is B. So the area of that would just be, this length multiplied by that length times 1/2, right? So it becomes 1/2 times, since this is 7 and this is 3, it's 4. 4 times this much, that's 3, right? So this is 6. And so this is the answer, it's A. Number 10, a particular 12-hour digital clock displays the hour and minute of a day. Unfortunately, whenever it is supposed to display a 1, it mistakenly displays a 9. For example, when it is 1:16 p.m., the clock incorrectly shows 9:96 p.m. What fraction of the day will the clock show the correct time? Okay, so this is just going to be equal to 1 minus fraction of incorrect time, right? We just want to know all the times with 1. Then that will just be 1 o'clock, or 10 o'clock, 11 o'clock, and 12 o'clock, right? Like that, right? So this is going to take away 4 hours already. So this is 4/12, which is 1/3. 1/3. This is taken out already. So we have 2/3 left. 2/3 of 12 hours left. And then now we need to consider the minutes. So we will take 0, 1 away and 1, 1, but that's also going to be later. So let's just not care about that now. So it's 0, 1, 2, 1, 3, 1, 41, and 51, and 10 to 19, right? 1 and 0 to 9, right? This is going to be 2/3, right? 2/3 times, and then this much is 1, 2, 3, 4, 5, and then 10 more, right? So that's just equal to 15, and that's all out of 60 minutes, right? So this is going to be 2/3 times 1/4. This is 1/6, right? So the fraction showing the incorrect time, this is going to be 1/3 plus 1/6. This is going to be 1/2, right? And so this is going to be 1 minus 1/2, which is 1/2. So this is our answer. It's A. Number 11. On Monday, Millie puts a quart of seeds, 20% of which are millet, into a bird feeder. On each successive day, she adds another quart of the same mix of seeds without removing any seeds that are left. Each day, the birds eat only 25% of the millet in the feeder, but they eat all the other seeds. On which day, just after Millie has placed the seeds, will the birds find that more than half the seeds in the feeder are millet? Since we notice that there's like a lot of 25%, right? So there's going to be a lot of 1/4 and then 3/4. And so it will be best to set our initial value to a large power of 2. And so let's start with 256, which is 256. This is going to, because this is to the 8th power, right? And so that means that we add 64 millet every day, right? The other seeds, there are going to be 192 other seeds, right? We want the time when the birds find that more than half the seeds in the feeder are millet. That means this has to be less than half of the seeds, right? And so we want the time when the amount of millet is greater than 192. And so now let's just get started. First, we have 64 on Monday, 64 millet on Monday. We're just counting the millets. And then Tuesday, we will have 64 divided by 4, which is 64 times 3 over 4, which is 48 left over, and then we will add 64 more. That will give us 112, right? On Wednesday, just to clarify, this number, it's the initial amount of milk at this day. So the next morning, so Wednesday morning, there will be 3 over 4 of 112, which is 84 left, and then we're going to just add 64 more, same thing, plus 64. This is going to be equal to 148, right? Same thing Thursday, because it's not greater than 192 yet. 148 times 3 over 4, that's 111, right? So 111 and then plus 64, this gives us 175. This is very close to 192. I think we'll get it the next time. And then we have Friday, and it's going to be 175 divided by 4 times 3, that's going to be 131.25, right? And the same thing, we add 64, that gives us 195.25, right? And finally, this is greater than 192, and so this is the answer. It's on Friday, so that means the answer is Friday. It's D. Number 12, the 5th and 8th terms of a geometric sequence of real numbers are 7 factorial and 8 factorial respectively. What is the first term? Okay, so since the 5th and 8th terms, there's a 3-term gap, and so that means 8 factorial over 7 factorial is the common ratio, third power, right? So that means common ratio is going to equal the cube root of 8, which is 2, right? And so we want the first term. So the first term, that's going to be 7 factorial over 2 to the 4th power, right? Because 7 factorial is the 5th term. So this is going to be 7 times 6 times 5 times 4 times 3 times 2 all over 16. So it's going to be, those are going to become 3. So this is 7 times 3 times 5 times 3. This is equal to 315, right? So this is the answer. It's E. Number 13, triangle ABC has AB equals 13 and AC equals 15, and the altitude to BC has length 12. What is the sum of the two possible values of BC? Okay, so we just want to pull out a diagram here, like this, right? This will be A, this will be C, and either this or this can be B, right? This can be B or this can be B also. That's because we know that this is 15 and B is 13, like that, right? And BC is length 12. That means this is 12. If you see, we know this value for sure because this is a right triangle and this is a 5 to 4, right? So that means this is 3, and so that means this much is 9. And we have 13 to 12 and a right angle, so that means we know this one, which is 5, right? And so this is 5, and this much, that's 9, right? And so our possible values of BC are this and this, right? So this value, that much is 9 minus 5, right? Because this whole thing is 9 and this much is 9, right? So this is going to be 9 minus 5, which is equal to 4, right? And we have also this value. This is going to be equal to 9 plus 5. That's going to be 14, right? Again, we have this value. This is going to be 9 minus 5, which is 4. And we have this value, which is going to be 9 plus 5 is 14. If we add them, so if we add them up, that's going to be 18. That's your answer. It's D. Number 14. 5 unit squares are arranged in the coordinate plane as shown, with the lower left corner at the origin. The slanted line extending from C, 0 to 3, 3 divides the entire region into 2 regions of equal area. What is C? Okay, so let's just find the area of the shaded region. Since we know that the whole thing is going to be 5 squares, right? So this is 5 squares, and so this much is in half. We get that this much, this is half of 5. This is going to be 5 over 2. And if we add this much, this square to the whole thing, then it's going to be a right triangle, right? So this area is going to be 5 over 2 plus 1. This is 7 over 2. This is going to be equal to the same as this length times 1/2, right? And so this much is 3, right? So 3 times, and then this much, which is 3 minus C, times 1/2, right? Times 1/2. So if these two are canceling out, that means 7 equals 3 times 3 minus C, right? So I'll write that 3 times 3 minus C over 2. And so 7 over 3 equals 3 minus C. That means C equals 3 minus 7 over 3, which is equal to 2 over 3. C is 2 over 3. So this is our answer. It's C. Number 15, assume r is between 0 and 3. Below are 5 equations for x. What equation has the largest solution x? Okay, so if we look at all of these, then we can see that they all have the form of 3, 1 plus something to the x power. This equals 7. This means x equals log 1 plus something of 7 over 3, right? And so for this to be the largest, that means that this small thing, this thing has to be smallest. If we compare those things, it's r root r, r over 10, 1 over r, and 2r. So we have r root r, r over 10, 1 over r, and 2r, right? We need to find the smallest, and so our smallest will be r over 10 because r is between 0 and 3, right? So this is going to be the smallest. So the one with this is the answer. So that's this one. It's B. Number 16, trapezoid ABCD has AD and BC are parallel. BD is 1, DBA is 23, and BDC equals 46. The ratio BC to AD is 9 to 5. What is CD? Okay, so if we bring out a diagram like this, then that means we're going to have A like that, B is going to be like this, and C is going to be like this, and D is going to be like that, right? BC to AD is 9 to 5, so if this is 9, then this is 5, right? And so now we want to draw a line parallel to AB right here, right? So that line is going to look something like this. And so since this and this length will be equal, so this length will be 5, so this is 5, and since the whole thing is 9, then this is 4. So this will be 4. We know that DBA equals 23, so this is 23, and since BDC equals 46, this much is 46. But since these two are parallel, that means that this angle and this angle is equal, and this is 23, right? But then since the whole thing is 46, that means we know this angle too, that's also 23. If we mark it out, then that means ABD, BD, yeah, let's say this is E, BDE, and the EDC, they all have the same angle. That means that we want CD's length, we want this length, but then since this is an angle bisector, that means that DB to BE equals DC to CE, right? So DB to BE equals DC to EC, right? And so this gives us that since DB is equal to 1, right? DB is equal to 1 to BE, which is 5, this equals DC to 4. So that means DC, this is equal to 4 over 5. And so this is the answer. It's B. Number 17, each face of a cube is given a single narrow stripe painted from the center of one edge to the center of its opposite edge. The choice of the edge pairing is made at random and independently for each face. What is the probability that there is a continuous stripe encircling the cube? Our total, that would be 2 to the 6th power. And then if we have a cube, then the probability that we want one steady loop encircling it. We have 3 possible ways of where to put this loop. So we have those 3 ways. So we have 3 ways of putting the loop multiplied by, let's say it's this loop we were putting it on, then we don't know what this and this face are going to be like, right? So that just has 2 squared possibilities. This is going to be 12, right? So it's going to be 12 over 2 to the 6th power. So it's 12 over 2 to the 6th power. This is 3 over 2 to the 4th power, which is 3 over 16. So this is going to be the answer. It's B. Number 18, Rachel and Robert run on a circular track. Rachel runs counterclockwise and completes a lap every 90 seconds, and Robert runs clockwise and completes a lap every 80 seconds. Both start from the start line at the same time, at a random time between 10 minutes and 11 minutes after they begin to run. A photographer standing inside the track takes a picture that shows 1/4 of the track centered on the starting line. What is the probability that both Rachel and Robert are on the picture? Look at Rachel first. Rachel runs counterclockwise and she completes a lap every 90 seconds, right? So Rachel, she does 1 lap, 1.5 minutes, right? And so this means she does 2 over 3 laps in 1 minute, because multiplied by 2 over 3. And so for 10 minutes, then she's going to do 20 over 3 laps. If we just pull out one track, right? Since she starts at the middle, right? So she starts right here, and she runs counterclockwise. She runs like that, and 20 over 3 laps just going to be equal to 2 over 3 laps, right? 2 over 3, and so she is going to start here and then run like that, and then 2 over 3 laps. That's starting from here, and the 1 minute more, 1 minute, she goes 2/3 laps. And so that means she will go from here this much, right? That much for her lap, right? So that will be from here all the way to here, like that. And next we will look at Robert. Yeah, so this is Rachel, like that. And then now we'll look at Robert. He completes a lap every 80 seconds. His will be 4/3 minutes to make 1 lap. And so that means in 1 minute, and that means he is going to be able to do 3/4 laps. In 10 minutes, he's going to be doing 30/4, which is 15/2 laps. That means he's going to start from 1/2. If we bring out Robert, then that means if we draw lines like that and like that, that basically means that he is going to start at half lap point. So at the half point, he goes clockwise. So he goes clockwise like that. And so that means he will run 3/4 laps in that minute. So that means he will go like this, right? He goes like that. And so now we have a photographer that is standing in the middle, right? And he takes a picture that shows 1/4 of the track that's centered on the starting line. And so that would be from here to here, with this being 90 degrees, right? And so this would be 45. So this would be 45 and this would be 45, right? Same thing here, like that and like that. This would be 45 and this would be 45. Okay, so let's go with Robert first because it's easier. If we separate everything like that, right, this green line, that's the amount he runs in 60 seconds, in 1 minute. And so that means that this is going to be the first 10 seconds, right? So this is going to be the first 10 seconds, and then so 10 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds, and this is the end of the 60 seconds. Yeah, so he's going to go from 30 seconds up to 50 seconds. So Robert, he's going to go from 30 seconds up to 50 seconds of the 1 minute right here. That's going to be the time when Robert is in the picture. For Rachel, it's kind of more complicated because the full angle is 120 degrees. This angle is 75 degrees. Since 240 degrees, this is 60 seconds. That means 75 degrees. This is going to be 75 times 1/4, which is 18.75 seconds. She will start at 18.75 seconds. Yeah, so she will start being in the frame at 18.75 seconds. Up to, and then we need this much, right? Up to right here, which is 90 plus 75. That means 165 degrees. This is 165 times 1/4. This is going to be equal to 41.25 seconds. So Rachel's going to go from 18.75 to 41.25, right? 41.25 seconds. And so we need to combine these two times. And so that means both Rachel and Robert will be in the picture from 30 seconds up to 41.25 seconds, right? And so this is 30 seconds up to 41.25 seconds. So that total is 11.25 seconds. 25 seconds. And then this is all over 60 seconds, right? And so this is equal to 45 over 60 times 4, right? And so this is equal to 3 over 4 times 4. This is equal to 3 over 16. 3 over 16. And so this is the answer. It's 3 over 16. It's C. Number 19. For each positive integer n, let fn equal this, right? What is the sum of all values of fn that are prime numbers? If we don't consider this, then we have n to the 4th power plus 400. That means n fourth minus 360 n squared plus 400. This equals n to the 4th power plus 40 n squared plus 400, right? And then minus 400 n squared. And so we know that this is a perfect square. So this is going to be equal to n plus 20 squared minus 20n squared. So this is going to be equal to n squared minus 20n plus 20 times n squared plus 20n plus 20, right? So this is fn. So this is fn. And fn wants to be prime numbers, right? So for fn to be prime, then that means one has to be 1 and the other has to be prime. N is a positive integer. That means this is always less than this, and so that means this must be 1. If we write that, n squared minus 20n plus 20 must equal 1. That means n squared plus 20n plus 19 equals 0. And so this is, if we factor this, this gives us n equals 1 or 19. And so if we plug them into this value, right, then that will give us the fn, because this is just because that's just 1. So that gives us n squared plus 20n plus 20 equals 41 when n is equal to 1, and when n is 19, that will give us 761, right? So 41 plus 761, this gives us 802. So this is our answer. It's E. Number 20. A convex polyhedron Q has vertices v1, v2 all the way to vn and 100 edges. The polyhedron is cut by planes p1, p2 all the way to pn in such a way that plane pk cuts only those edges that meet at vertex vk. In addition, no two planes intersect inside or on Q. The cuts produce n pyramids and a new polyhedron R. How many edges does R have? If you look at any convex polyhedron, like let's say a cube, right? Then this just means that it's going to be cutting like these corners, just literally cutting corners. And for polyhedrons where 4 edges intersect like that, right, then it's also going to cut off like this, right, like this, and this, like that, and so on, right? So here we notice that every cut makes as many new edges as the number of edges that met on that vertice, because for this one we have 3 lines meeting on the vertice, right, and the cut made 3 more edges. And same thing for here, we had 4 vertices meet on here, and the cut made 4 more edges. Since we have 100 edges total, right, since we have 100 edges, that means we have total of 200 more edges, new edges. The reason that it's multiplied by 2 is because each edge has 2 endpoints, right? So it has so it's connected to 2 vertices. So that means that it's going to be counted twice, right? And so every vertex is going to be counted twice. That means that gives us a total of 200 new edges. And so now we just do 100 plus 200, because 100 is the old edges, and 200 is the new edges, right? So this is going to be equal to 300. And so this is the answer. It's C. Number 21. 10 women sit in 10 seats in a line. All of the 10 get up and then reseat themselves using all 10 seats, each sitting in the seat she was in before or a seat next to the one she occupied before. In how many ways can the woman be reseated? First, we have to notice that the woman can either stay, which requires just one person, or they can just swap, right? Swap, which requires 2 people, right? 2 people to just swap like that, right? Now it's just a problem where we just counted for all stay, or 1 swap, 2 swap, 3 swap, all the way to 5 swap, right? And so if all the women stay at their seats, all stay, that means we have 0 people who swap, right? So that's just 10 choose 0, because 10, this is the number of stay plus the number of people who swap, right? And so this is 10 choose 0, and 1 swap, that will give us 9 choose 1, because we have 1 swap. This is the number of swaps, and this 9, this is the number of stay plus the number of swaps, right? So we have 8 stay and 1 swap, right? Because 1 swap takes up 2 people. So we have 9 stays plus swaps and then we have 1 swap, right? And then next, same pattern. If we have 2 swap, that would be we have 8 total, right? So 8 choose 2. Because we have 2 swaps, that means we have 6 stay. That's just 8 choose 2. And so if we have 3 swap, that will give us, by the same pattern, 7 choose 3. If we have 4 swap, that will give us 8 choose 4. Sorry, that will give us 6 choose 4, right? 6 choose 4. If we have 5 swap, that will be just 5 choose 5. And we can't do any more because there are 10 people in total, so the maximum number of swaps is 5. And so this is just equal to 1. 9 choose 1, this is equal to 9. And 8 choose 2, this is equal to 28. This is 35. This is 15. Yeah, that's 15. And 5 choose 5, that's just 1, right? And so if we add up these numbers, then that gives us 89. That's the sum. So this is the answer. It's A. Number 22. A parallelogram ABCD has an area of 1 million. Vertex A is at 0, 0, and all the other vertices are in the first quadrant. Vertices B and D are lattice points on the lines y equals x and y equals kx for some integer k is greater than 1, respectively. How many such parallelograms are there? We can just draw this out, right? Even though we don't know a lot of it. We know that this is A, so this is 0, 0. Let's say B is on y equals x and D is on y equals kx. And so we will have this point B, B, and we will have this point, which is d comma kd, right? Because it's on y equals kx, right? So it's d comma kd, and we will have c somewhere here, right? And so yeah, c will be like, I don't know, here, right? And so if we connect a and b, connect a and d like that, right? This is a, b, d. So c is going to be something like somewhere here, right? So this is going to be c. And so we know that ADB, like that. So this much ADB, this is half of the total area, half of 1,000,000,000, half of 1,000,000. This is just 500,000. But then we know the coordinates of all 3 points. That means we can use the shoelace theorem. Shoelace theorem, right? So this is going to give us that the area is 1/2 times the absolute value of, and then we have 0, 0, 0, 0, b, b, d, kd, and 0, 0. So these are going to cancel, and these are going to cancel. So this is going to leave us with 1/2 times the absolute value of, absolute value of bd minus bkd. But then since k is greater than 1, that means this whole thing is minus. So this is going to be equal to 1/2 times bd times k minus 1, right? And this is equal to 1/2 of 1,000,000, right? So this is equal to 1/2 of 1,000,000. So we can cancel these out. So that will give us that, So that will give us that b times d times k minus 1. This is equal to 1,000,000. And 1,000,000, that's just equal to, this is just equal to 2 to the 6th power times 5 to the 6th power, right? The ways of dividing 2 to the 6th power into 3 slots, that is going to be 8 choose 2, divided into 2's. So that's going to be 8 choose 2, and then same thing for divide the 5's. This is also going to be 8 choose 2, right? And since 8 choose 2 is 28, this is also 28, and so we just multiply those together, so it's 28 squared, which is 784. 784, right? And so this is our answer, it's C. Number 23, a region X in the complex plane is defined by S equals that. A complex number z equals x plus iy is chosen uniformly at random from S. What is the probability that this times z is also in S? Okay, so let's first draw the coordinate plane. And we're going to have it like this and like this. And so this is x, this is y, this is the complex plane. And our boundaries are x should be between -1 and 1. Right, so x is between -1 and 1. And y is also between -1 and 1, right? We will adjust that, like that, and like that, right? That's more 1, -1. And so we know that this is 1, this is 1, this is -1, and this is -1, correct? And then next, since we want this, we'll just multiply them together. So it's 3 over 4 plus 3 over 4i times x plus iy. So this is giving us 3x over 4 minus 3 over 4y plus 3 over 4 times x plus y I, right? So this is giving us that since these have to be inside S, that means these two must also obey these things. So we know that this and this, they must both be between -1 and 1. So this is giving us that 3x over 4 minus 3y, so that's just, so this is 3 over 4 times x minus y is less than or equal to 1, and -1 and this thing, so 3 over 4 times x plus y is less than or equal to 1. So this will give us 4 things. From this is x minus y, this is between, this is between -4 over 3 and +4 over 3. Same thing over here. X plus y, this is less than -4 over 3. This is greater than -4 over 3 and less than 4 over 3 itself, right? And so here, from this, we're going to get that y is less than or equal to x plus 3 over 4, and y is more than or equal to x minus 3 over 4. From here, let's do this in blue. And from here, we're going to get that y is greater than or equal to minus x minus 4 over 3, and y is less than or equal to minus x plus 4 over 3. And so if we graph those lines here, then it's going to be like here, like that. like right there, and right there. And we have the blue ones, those are going to be about here and about here. The area that we want is the area that is inside here, so this octagon, right? And this octagon is just going to be the whole thing, which is 4 minus 4 of these things, right? And if we zoom in, since we know that this point is minus 4 over 3, and this point is 4 over 3, this much is 1 over 3, right? And so since the whole thing is 1, that means that much is 2 over 3, right? So if we say this is 2 over 3, then this is also 2 over 3, right? And so the area of one of these, this is going to be 4 times, so the area of 4 of these, that's going to be 4 times, and then 1/2 times 2 over 3 times 2 over 3. This is going to be 8 over 9, right? So since we know that the whole thing is 4, so this is going to be equal to all over 4, and then we have this 4 minus this, right? So 4 minus 8 over 9, and so this is going to be equal to all over 4, and then 28 over 9, right? So this is going to be equal to 28 over 36, right? And so we have 28 over 36 now. This is equal to 7 over 9, and this is our answer. It's D. Number 24, for how many values of x in 0, pi is sine to the negative first power of sine 6x equal to the cosine inverse of cosine x, right? This is the sine inverse and this is the cosine inverse. They are inverse trigonometric functions, right? And so since here, from just the definition of cosine inverse x, we know that the domain of cosine x is the range of cosine inverse x, and also because of this, the domain of cosine inverse is going to be the range of cosine, right? And so the range of cosine x is also going to be equal to the domain of cosine inverse x, right? And so this just gives us that this whole thing, so cosine inverse of cosine x, this is just going to be x. Since this is equal to x, this gives us that sine inverse and then sine 6x equals x, right? And so if we move this over there, then that gives us that sine x equals sine 6x. Since x is between 0 to pi, then we can just draw the graphs of sine x and sine 6x for 0 to pi, and now we can get the answer, right? If we do that, this is pi. We will look at the number of intersections. So this is sine 6 pi, that's sine 6 pi, and this is just sine x, right? And so this is 1, 2, 3, 4, 5, 6, 7 intersections. So this gives us 7 intersections, right? So 7 is our answer. It's E. Last problem, number 25. The set G is defined by the points x, y with integer coordinates, and x and the absolute value of x is between these, and same thing for y. How many squares of side length at least 6 have their 4 vertices in G? Okay, so first of all, let's say square is ABCD. Square ABCD exists, but all of its corners, so A, B, C, and D, are on all the 4 quadrants, right? For example, this will be A, this part will be B, and this will be C, and this will be D, right? That's going to make a square, and it's on all 4 quadrants, so that also is correct. And now we are going to apply an interesting transformation. We're going to make A just the same as A as it was before, and then we're going to make B go B plus 10, 0. So it's going to slide 10 to the right. And then C is going to go C plus 10, 10. So it's going to slide 10 right and 10 up. And D, this is going to become D plus 0, 10. So it's going to slide 10 up, right? And so if we do that, I will just show it with the green color. So A will just stay where it is, and B will go 10 positive, right? So this is A and this is B. This is the new B. And C will go 10, 10. So it's all over here. So this will be C. And D, that will be all the way over here, right? So this is D. And so now what we notice from this transformation is that A, B, C, D, they are all on the same point, or they form a square, on one quadrant, right? So we see from this that this is true. They form a square on one quadrant, which is this quadrant, and they can all be on the same point if let's say that the starting points were these four. No, let's say the starting points, they were these four, right? Then they would just all have ended up on there, right? They are all on the same point or form a square. So since we have 25 points, that would give us, so the total number, so the total number, this would be equal to 25 for the ones that are on the same point. So because we have 25 points plus 4n, when n is the number of squares possible on one quadrant. And the reason for this 4 is because that quadrant, so that means this quadrant can be either this one or this one or this one or that one, right? And so there are 4 possible things, so that's why it's 25 plus 4n. Now, if we get the n value, it's all over. But then first, let's look at the answer choices. If we look at the answer choices, that means first n has to be an integer, right? So if n is an integer, that means the total number would be 25 plus the 4n thing, right? And so the only things that match that is a and e. A or e, because a is when n is equal to 25, and b is when n is equal to 50. So we have either a or e, and b, c, d, they are not even in 25 plus 4n form, right? So it's either a or e. And now let's just look at the number of n's, right? So let's try to count the number of n's. And this is going to be greater than or equal to the number of just like straight squares, right? Straight squares, nothing kind of curved like this one, like that, but like just straight squares, right? Then we're gonna have, this is gonna be 1 by 1 plus 2 by 2 plus 3 by 3 plus 4 by 4, right? So this is gonna be greater than or equal to 1 by 1, we have 16, and we have 2 by 2, we have 9 of those, plus 3 by 3, we have 4 of those, plus 4 by 4, we have just one of them. So n is going to be greater than or equal to 30. That means n equals 25. That is impossible. That means, sorry, this is not b, this should be e. This should be e. And since a is not possible, that means e is the only answer. That means this is the answer, it's e. So that was it for the AMC 12B from the year 2009, and thank you for watching.